Alrighty. So today we're going to be in chapter 1. This is where this journey will start us off. Chapter 1 is dealing with just equations and inequalities. So hopefully you find this to be pretty straightforward. What makes this difficult is every type of equation and inequality, not just your typical polynomials where you're just solving for x or factoring. There's some rational, there's some radicals, there's some exponential. There's just all, it's us all in one. But we'll start off basic and then progressively get harder. We're going to start off in section 1.1, which is just going to be equations and rational. So linear and rational equations. Sorry about that. Linear and rational equations. If you don't know what rational is, it's basically just a fraction. You will see the word radical. That's a square root or a cube root or a fourth root and all that great stuff. Good, good, good. We are then going to focus on objective 1, which is just solving linear equations in one variable. So basically just solving where there's only one letter involved. There's just either an X or just a Y or just an M or just one single letter. Alrighty, so if we go straight into one, let's look at one like this. I'm not going to bore you with the most basic, but I will get into a little basic. But if we look at something like this, -5, parentheses, u minus 4, close parentheses, plus 2 equals 11 minus parentheses, u minus 3. All right. I would say this is pretty basic for college algebra. What would I do first? Distribute. We got to get rid of parentheses. All right. So here, this is pretty straightforward. I can just take this -5, distribute it in. Do I distribute it to the 2 over here as well? No, only to things in the parentheses. Very good. -5 times u would be, very good. -5 times -4, very good. Plus 2. Now over here, do I distribute the 11 and the negative in there? Very good. It's like a -1 there. Now I'll take that and distribute it. What does it basically do to everything inside? Very good. So I end up with what? Very good. All right, now that I have the parentheses gone, what's my next step? Combine like terms on the left and the right side before we start moving things over. I can see that I have 2 constants, so let's make that just 1. What's 20 plus 2? Very good. And then I see that I have 11 and 3. Now, it doesn't matter how you write this. I am very standard, so I will always write the letter first and the constant. So I'm actually going to write it -u first. But if you wanted to write the 14 first, then the -u to make it there is not a negative, by all means you can. I just like it in that order, but I don't specify on how you solve it. All right, now that everything is combined on the left and the right side, what can I do now? Very good. Get the U's on one side. It doesn't really matter to me. What do y'all prefer? So you like moving everything to the left? That is perfectly fine. A lot of kids like to go have the U on the left. I prefer to avoid negatives, so I'd probably move my 5 over because I don't want to have to deal with negatives. But it's actually not that big of a deal when dealing with equal sign. I will say when we go into inequalities, moving the letter to the left side is the best practice because the inequality sign will tell you which way to shade when we get to that point. So maybe just moving everything to the left to begin with might be the best practice. All right, so how do I move that left, the negative u over? Just add u, just do the opposite operation. So that will give you what? Sorry, -4u. Now, I don't expect you to do this, but in college algebra, you are limited on time, especially when it comes to tests. You have unlimited on the homework, amount of times you can do it. So you do want to pick up some quick, faster techniques. So instead of adding the u over and then doing the rewriting and doing the next step, what would the next step be? What would the next step be? We got the u's over. What would be the next? sending the 22 over, right? The goal is to get the u to one side, get the constant to the other. So instead of rewriting another step, I'm going to do 2 steps in one. I don't require you to do that, but the goal again is to get a little bit faster. So I'm going to subtract 22 to both sides. So when I do that, 14 minus 22 is? Very good, -8. Yes, ma'am. Meredith? All right, so we get -8 here. Again, if you wrote this out as 2 separate steps, that's what you would get. What would be your next move? Division, right? I'm going to divide both sides by the -4. So -8 divided by -4 would be what? +2. On the test, I'm good with this right here as your answer. You can circle, box it, leave it the same. You're okay. However, on your homework, and I kind of told you this a little bit on the review, they like their answer like this, where it represents that 2 is in a set of numbers, just in case you get multiple numbers. But for me, you can just say letter equals whatever, and I'm good. Yes, 2 negatives make a what? Positive. Questions on that? I will say when dealing with linear equations, when you get the answer, you're done. When we get into rational equations, there is some limitations that you got to make sure you don't get answers of. But we're good with the basics. All right, good deal. All right, so then if we move on, let's look at a rational equation, a basic one, before we get into a more complicated. Yes? Oh, where numbers fall in there? It's all right. I don't test you over it. But talking about rational, irrational, integers, whole numbers, natural numbers, real numbers versus imaginary, complex numbers. I'll never actually ask you what this number is. You just got to know the form that we write it in. But other than that, you're good. But it is typically like the first thing you always talk about in every math class. That's like one thing we talked about in pre-cal. That was the first thing, right? Yeah. It does, yeah. And then you never see it again. Really, what mathematicians or math teachers like to do that with is if we say those words, like if I say, hey, what's an integer that I'm looking for here? The goal is to not have a blank face and know that it needs to be a whole number that's either positive or negative or a zero, and not basically a fraction or a decimal. That's where that kind of comes. Or if I ask for a whole number, it's a zero or greater, but 1, 2, 3, 4, or natural number is the same thing, just not including the zero because it's not natural, things like that. But it's just so that we could say it and then you comprehend, but you never really get tested over it. All right, here you go. So we got t minus 2 over 3 minus t plus 7 over 5 equals t minus 4 over 10 plus 2. This is exactly what your estimate has been in class. I need to figure out what the least common denominator of 3, 5, and 10 is. If you don't know it, no big deal. You can always break it down into their prime factorizations. If you do know it, figure out what you got to multiply everything by. Here we go, though. For sake of note taking, we're going to find the least common denominator. So I'm going to write down every denominator. I'm going to write the 3, I'm going to write the 5, and I'm going to write the 10. The goal is then to turn all of those into a prime factorization. A prime factorization is all the numbers that would multiply to that number that are all prime. But is 3 a prime number? Just an FYI, prime are numbers that can only be divisible by 1 in itself. So can you think of another number that 3 could break into? No. 9 would be greater than 3. What two numbers could break down into 3? Like what multiplies together gives me 3. Right, that's it, right? 1 in itself. So 3 would then be a prime number. What about 5? Prime number. What about 10? What two numbers multiply to 10? 2 times 5. So your prime factorization of 10 would then just be 2 times 5. Now, then you ask yourself, is 2 a prime number? Yes. Is 5 a prime number? Yes. So I now have 10 broken down into a prime factorization. So that's what that means when I say prime factorization. The next step you would want to do is figure out what that LCD is. To figure it out, I'm going to write every number I see one time. I see a 3, I write a 3. Cancel any 3s. I don't have any 3s to cancel. I see a 5, I write a 5. So that's going to be times 5. Cancel any 5s I see. I see a 2, I write a 2. Cancel any other 2s, but that's it. He just figured out all the numbers? Great. I will say this, it only cancels one number in each row. So let's say, hypothetically, this was 2 times 5 times 5. Let's say we were doing 50 or something like that. No. Yeah, that'd be 50, yeah. Then I would only cancel one of the 5s. I would still have to write another 5 down. So it does cancel, but only cancels one number in each row. So if this, like for instance, right. So if like for instance this was 15 and I had 3 and 5, I'd write 3. Obviously there's nothing there. I would write 5. I would cancel this 5 and this 5. And then I wouldn't have to write 5 again. So just keep that in note. All right. So therefore, after you figure out the numbers that they really don't have in common or have in common or don't have in common, really is what you're looking for, is what's 3 times 5 times 2? 30, right? 3 times 5 is 15, times 2 is 30. So your least common denominator of 3, 5, and 10 is 30. Now, you might have looked at that and go, well, yeah, that's obvious. That's fine, go with it. But sometimes it's not. Sometimes it might be like 15, and you might not have seen that. But 30 would be the least common number. Now, once you determine this, all you got to do is figure out what number do I need to multiply 3 to make it 30? 10, right? But if I do that, oh, sorry, my bad. I'm going. You do this. Sorry, refrain from that last step. You do that part if you're just simply adding, subtracting the fractions. I have an actual equation. All right. I don't like fractions. I'm going to get rid of the fractions by multiplying by the least common denominator. So I'm actually not going to even focus on what do I need to multiply 3 to make it 30. That's what you would do if you were just adding or subtracting 2 fraction expressions. In an equation, I'm actually just going to multiply the entire equation by the least common denominator. What do you mean? Yes, that's exactly what a least common multiple is. What is the smallest number that they can all go into? That's exactly it. That's what that means. If you know that it's 30 immediately in your head, no. And right now, these are small numbers. You might be able to look at it, but had this been like 98, 42, and 10 or something like that, that might be like, oh, like I say, if it was 98, 42, and 10, I couldn't tell you what it is. I would have to break it down. Right. Yeah. If it's small numbers, I kind of expect you to be able to just look at this and just know what the number is. That's fine. We might. We got some time. All right. So then after this, basically what you're doing is if I multiply by 30 and I'm dividing by 3, I'm really multiplying this guy by what? 10. So that 3 will go away. I'm really multiplying by 10. Okay. You can technically, if you want, multiply by 30, then divide by 3, but you'd get back to the same conclusion that you're multiplying by 10. Do we understand where the 10 came from? Okay. Go to the next one. And you notice I'm putting in parentheses so I remember to distribute this number. If I'm multiplying by 30 and dividing by 5, I'm really multiplying by what? 6. So I'm really just multiplying by 6. 6. There we go. I got t minus 4 over 10. If I multiply by 30 and divide by 10, I'm really multiplying by 3. And here, I don't have any fractions, so I'm legit multiplying 2 by what? 30, right? And now we're going to go do the math. So I'm going to rewrite it before we do the math, but you're more welcome to do the math before you rewrite it. It doesn't matter to me. But to clean it up, I'm really doing 10 times t minus 2 minus 6 times t plus 7 equals 3 times t minus 4 plus I'm going to go ahead and just do it. But 30 times 2, if you want to make that into 60, that's fine. Now we have an exact problem that we just did in example 1. What do I do first? Very good. So the goal of a rational equation is to turn it into a linear equation, so it's a lot easier for us to solve. All right, here we go. So I'm going to take the 10, distribute out, so I get 10t minus 20. Am I multiplying by just a 6? Good. That minus sign will be attached to that number. So when I distribute, it does become negative 6t minus 42. Then come over here, equal 3t minus 12. And then that's a big multiplication sign there, plus 60. So just like in the previous question, what's my next move? Just combine like terms. So I see I have a 10t and a negative 6t. That will turn into a 4t. I then see I have a negative 20 and a negative 42. So that would turn into a negative 62. Again, we are allowed the blue calculus, but I love how you're trying to do it in your head. That is where we're kind of trying to go to. All right, I actually don't have any. Oh, there, that's a t. So I'm just going to drop down the 3t. Again, I like to write it in standard form. And then negative 12 plus 60 is 48. Positive or negative? Positive, and I write a what to represent that? A plus sign. Very good. My t's are looking like a 6 there. No, it's actually a. No, you're doing just fine. We haven't gotten to that stage yet. All right, what's your next move then? Good. I'm going to move the t over, and I'm also going to move the constant to the right as well. I'm going to do 2 steps. T to the left, constant to the right, right? T to the left, constant to the right. So I'm going to subtract 3t, always lining up my like variables. Add 62. Again, line up your variables. Bring your equal sign down. So 3t plus, oh, my bad, that should be a negative. 4t minus 3t is a t. Don't forget to carry the sign with it like I did. Make sure you remember it. All right, and then 48 plus 62, 110. All right, that is actually your answer. Now, caution. Is there any t's in the denominator? No, no stress. If there are t's in the denominator, you don't have to plug it in. Just find out what t can't be. So if this was like t minus 3, what could t not be? Plus 3. Make sure that answer is not that. All right. So that's the only thing extra you have to do with rational equations. If you have t's in the denominator, figure out what it can't be. Make sure your answer doesn't have that answer. You cross it out, doesn't become your solution set. So again, I'd be looking for this. Your homework will probably make you put it in a set. Okay. If you had multiple answers, I think they go least to greatest, but I also don't think they really mind as long as it's in the set. All right. Questions on that? So objective 1, we're looking pretty good. All right, just like any solving equation problem, there is word problems. So let's do one. Number 3, bear with me with all the writing. It's a simple one though. So it says a subway ride is $2.25 per ride. Question A says write a model for the cost. We'll count, that's a T. We'll count cost as the letters capital C, and this will be in dollars for X rides on the subway. And we'll pause there. First of all, when it says write a model, what does that tell you? That's it. You got a word problem. It wants you to write an equation specifying with the letters that it tells you to use. So I want to use C for my cost, X for my rides. With the information that says a subway ride is $2.20 per ride, What is your equation? Good. How do I know this is next to my x? Per. Per means to do what? Multiply. So we'd multiply next to our variable. You're right. So that'd be 225 times ride. Well, ride represents the letter x. So how would you write this equation out? Nope, we're just writing an equation. Very good. Typically, we like to write the c first. Also, we like to write it as a function. I will tell you, if you wrote this on a test, I probably wouldn't count it wrong. I'm pretty ecstatic that you got there. This is how you're supposed to write it. In function notation, you would write c of x equals this. And we write it on the left side. No, because 2.25 is how much each ride is. The x here would represent how many rides you actually do. So if I wanted to know how much would it cost for 10 rides, then it will become c of 10, and you'll replace this x with a 10 to actually multiply 10. So you would actually leave this as x there.
That's you put 10 there and it'll still.
Oh, like that? Oh, I thought you meant you put the 225 in there. Oh, technically, yes, you're not wrong by saying x times 225, but that's not proper. Proper would be putting the number first, then the letter. Again, I probably wouldn't count it wrong. Homework might. It actually looks gross. You put the number last, just an FYI. But that's it. All right, so here's the second part of the question. Oh gosh, this is a long one. All right, here we go. A computer, nope, can't read. A commuter can purchase an unlimited ride Metro card. Gosh, my handwriting is horrible today. For $89. My handwriting looks like the stuff you see on Facebook that's not really words, it's just a bunch of scribbles, but you know what it says. All right, so Metro card for $89 per month. How many rides are required for a commuter to save money by buying the Metro card? Same process. A subway ride is $2.25 per ride. So how would I figure out how many rides I would need so that we start saving? How did you conclude this? How can I find the exact answer? What does the 89 represent? The cost. That's it. Right? Now, on a test, common sense to figure out the answer, love it. Do it. On the homework, I'd ask more for specific answers. Right? But yes, 89 would be the cost. So I'd plug that in, equals 225x. I would simply take that number and divide. And what does 89 divided by 225 give me? Ooh. You said the answer was 9? 89 divided by 225 is 39.5 repeating. I can tell you this, 225 times 10 is only $22.50. So you, yeah, if you multiply by 10. So 2 days would cost you $4.50. Yes. Oh. Bye. All right. So we agree with the math now? Okay. Is 39.5 my answer? How many rides are required for a commuter to save money by buying the Metro card? Can you ride half of a ride? Are you just going to jump off in the middle of it? I think that still counts as a ride. Very good. I cannot have that half day, or half a ride, but the 40th ride would then mean I'm now saving money. So the answer here would actually be 40 rides. Gotcha. The math, not mathing. Very good. Any questions there? All right, objective 2. $250 times 10 is still $25. $2.50 for 10 rides is $25. You still wouldn't be. Yes, if it was $8.90, yes. If it was $8.90 a ride, 10 days would finally make you money. Nice. Objective 2. Identify conditional. That's not how you spell it. Conditional, there's an I in, or T in there. Conditional equations. Well, it has to be because I literally just copied it out of the book. Conditional equations. Identities. And contradictions. In this objective, the goal is really not to, well, it is. You're going to solve it, but then you'll end up with like special cases and then what to call them. So, for example, Fun, right? Fun. I don't know what we're on example 4. It's not. No. We're going to take 4 times 3 minus 5n plus 1 equals -4 minus 8 minus 16n. Our goal is just to solve it and see what kind of answer we get. What would be the first thing you do? Is to write the question down. You are correct. And then distribute. Yep. FYI, I will have no after-school tutorials this week due to science meetings at the end of the day. Do apologize. Before school, I'm still available. All right, so we get 12 minus 20n plus 1 equals -4 minus 8 minus 16n. What's the next move? Very good. I get -20n. 12 plus 1 is 13. Bring down the -16n. Again, you don't have to. It just looks better. -4 minus 8 gives me -12, right? Next move. Sling it over. Plus 16n. Plus 16n. There we go. -13. -13. Sling the n over. Go ahead. It's right there. No. Yeah, so when you add it over, it should be positive. Yeah. It's all right. It's all right. It happens to us. Negative 20 plus 16? In. Yeah, don't forget that part. Negative 12 minus 13? Negative 12 minus 13. It does. Hold on. Did I write I did write the question down wrong. Yeah, this actually gives you an answer. We don't want an answer on this one. No, we were doing it right. I just didn't write the question down right. No, I just forgot to write an in here. They don't give me steps. It just gives me the question. No, this was supposed to be negative 4 in. And then I'll bring the negative 4 in. All right, so let's start from this part. The only thing is I missed that in. Okay, we were doing it completely right had that been the actual question, just FYI. Now we would combine like terms, so that would be negative 20 in plus 13. So that's still all correct over here. But it should have been negative 20 minus 8, or negative 20 in minus 8. I'm over here telling you don't forget the end, and I forgot to write the end at the very beginning of the problem. So then we end up with this situation, and then what would we do? Sling it over, right? So then this will be positive 20 in, positive 20 in, negative 13, negative 13. Oh no, don't die on me in the middle of the lecture. That would then go away. That would go away. What's left on the left if everything goes away? There is something. What is it? No. No. If nothing is there, what number do we represent that at? 0. A lot of students will forget that 0 is the absence of something that represents nothing. But 0, does it equal, is that negative 21? Is that a true statement? No, this is called a contradiction. So the way they want you to answer it, it is a contradiction. That's the one it is. Contradiction. And the answer will be an empty set. There'll be brackets with nothing in it. Okay. Due to time, I will finish 1.1 tomorrow, get into 1.2 for the next 2 days. We'll find out about Alex, and then when Alex starts, all the homework will then catch back up. So you might have a pretty full load when we first get Alex, but then I'll slow down. Okay. I know. By tomorrow, if you don't mind. All right, so let me go ahead and end that.